The final subtopic of Chapter 8 is called 8.3 Continuity. And in this subtopic, we're gonna have two parts. The first one is to find whether fx is continuous at any point x equal to c. So, if you need to show that fx is continuous, there are three conditions. The first condition is fc is defined. So, understand that fc means that you're substituting x equal to c into fx. So, that will give you fc. The second condition is the limit of fx as x approaches c exists. So, if a limit exists, this means that the limit of fx as x approaches 3 from the left-hand side should be the same as the limit of fx as x approaches 3 from the right-hand side. So, if you can show that both limits are the same, hence you can make the conclusion. For the third condition, you need to compare condition 1 with condition 2. For condition 1, you find fc. And for condition 2, you find the limit of fx as x approaches c. And then you compare both conditions. If they are the same, therefore you can make the conclusion that fx is continuous at x equal to c. The second part is finding the points of discontinuity. Just imagine that you have this x-axis and y-axis, and say that you have a vertical asymptote at x equal to -1 and x equal to 2. So, note that when there are vertical asymptotes, this means that there is no graph at x equal to -1 and x equal to 2. And hence, this means that there is no f-1 and f2. So, if there is no graph at f-1 and f2, hence you can make the conclusion that the graph is not continuous at x equal to -1 and x equal to 2. So, what does this mean? This means that your vertical asymptote is the points of your discontinuity. It is where x equal to something is the point where your graph is not continuous. So let's look at the steps for finding points of discontinuity. There are two steps. The first one is to state your vertical asymptote. Say that you have two asymptotes, so x equal to a and x equal to b. If they are vertical asymptote, this means that f equal to a and f equal to b does not exist. So they are undefined, and hence fx is not continuous at x equal to a and x equal to b. So this is the same meaning as saying x equal to a and x equal to b are the points of discontinuity. So let's look at this example. You need to determine whether the following functions are continuous or not. So what does it mean by a continuous function? Continuous function means that you can draw the function fx without lifting your pen. So it's just drawing your function in one stroke. So let's look at this example A here. Is this function a continuous function? Note that we can draw fx without lifting our pen, and hence fx is a continuous function. Let's continue with part B. This graph looks almost the same as part A. So let's see if it is a continuous function or not. Note that in order to draw this fx, you need to stop at x equal to 4, since at x equal to 4 there is no graph. Only then you can continue with your function fx. So you cannot draw fx without lifting your pen. You need to lift your pen in order to draw this graph. And hence, this fx is not a continuous function. What about part C? This is our graph fx, and to draw fx, you need to lift your pen. Therefore, this fx is not a continuous function.